If you know just one trigonometric ratio, you can able to find the height of a building without climbing it. So yes, today let's see heights and distances. It's a special application of trigonometry with which you could able to find the heights and distances, comparing all those objects with respect to right angle triangle and just evaluating and finding the unknown quantities based on trigonometric ratios. So let's see. So in this, we have to know three different things: angle of elevation, angle of depression, and line of sight. So these three are very important in this aspect. For whatever question you would like to solve based on this scenario, you should able to know angle of elevation, angle of depression, and the line of sight. So let's see what is angle of elevation and angle of depression and line of sight respectively. Now, angle of elevation or elevation angle in short. Say I am taking a ray, fixed ray and revolving ray, which means this is fixed and this is rotating, and this be an theta e. So here elevation, angle of elevation in the sense from a particular fixed array, from with respect to a fixed array, if the angle, if the rotating array is above the fixed array, which means the angle is or you could also call the elevation angle as an angle which is of the form which is of the range 0 degree to 180 degree. In the sense, the fixed array should be in fixed direction and the rotating array should be above the fixed direction, and it should be and it should revolve like a semicircle like this. So you are visualizing this, I guess. So this is the fixed array and this is the rotating array. So you should able to see the angle spread over should be in the range of 0 degree to 180 degree. So this is called something called elevation angle. And angle of depression means, so let me draw the angle. So the fixed array is this one, and the revolving array would be below the fixed array. I will denote it as theta d. So we from this you could also deduce that anti-clockwise angles are always profoundly called as elevation angles, and clockwise angles are always called as depression angle. So this is with respect to the direction of fixed ray. So the fixed ray is considered here. With respect to fixed ray, the angle, if the angle is rotating anti-clockwise, then it is called rotating ray. And same with respect to fixed array, if the angle is rotating clockwise, it is called depression angle or angle of depression. So the depression angle ranges from 180 degree to 360 degree range. So whenever if there is a like if there is a situation demanding the fixed array, revolving array is below the fixed array, then it comes under depression angle. So now let's see what is line of sight. Line of sight is typically known as the fixed array in other words. So the fixed array, the line of sight is the thing which through which you could judge whether the angle is either elevation angle or a depression angle, and it's just a medium, it acts as a judge. between elevation or depression, and it's the fixed array through which we would deduce whether it's an elevation angle or a depression angle. So this is called line of sight. Okay, so let's take an example in the sense in the form of derivation. So in order to find how this heights and distance could be found using the applications of trigonometry ratios. So let's consider a tower, and this is a tower is in a right angle shaped one, and you could write it like this. This is an alpha angle and this is a beta angle, and this is something called Q. Sorry, like this. A, B, P, and Q. Let PQ be A. Let PQ be A. And let the angle of elevation of top A of the tower as seen from B is beta, and as seen from as seen from B is alpha, and as seen from Q is beta. Let us consider it like that. So which means angle APB is equal to alpha, and angle AQB equal to beta. This is what they would like to tell. And from the given triangle APB, we can deduce tan alpha as AB opposite divided by adjacent. Adjacent is what? BP, right? Right. I would just take that. AB by B. Okay. Here we mentioned it as A, and let's mention this as Y, and let's mention this as X. Sorry. Oh, so which means X by A plus Y. This is tan alpha. So A plus Y can be written as X cot alpha. Let's keep it aside. And then same way from another triangle, which is AQB. We can get tan beta as X by Y. Sorry, tan beta as X by Y. So X by Y is nothing but which means we can write Y as X is equal to like Y is equal to X cot beta. So substituting that, A plus X cot beta equal to X cot alpha. Now we end up getting A as X of cot alpha minus cot beta. So if there exists a situation like this, where you would be given a situation where if from a particular reference frame, the angle, the elevation angle of a tower is beta, and if you go some a distance far from Q, you would get a point called P, and the angle of elevation from that to top of the tower is alpha. Then you would get this type of scenario, and the answer would be like this: A plus Y would be X cot alpha, and Y is equal to X cot beta, and A is equal to X of cot alpha minus cot beta. So this is what if we wanted to find the distance of P and Q. Okay. So the situations would be more likely similar like this. So there are just two or three different examples only, which deals with angle of elevation and angle of depression. The same thing with respect to angle of depression, it would be different. The angles, the ratios would behave differently. For example, the same triangle, if you consider with the perspective of top of the triangle, then the ratios would be different. The y plus a would be acting as the opposite side, and x would be acting as the adjacent side, and you would get the polarizing ratios in terms of if you wanted to find a, then you would be getting it as something like x of tan alpha minus tan beta, something like that. So this is how it behaves. Why? Because with respect to the top of the tower, the angle would act as a depressing angle. And with respect to the bottom of in the ground, the angle acts as the elevation angle. So that's why there is a difference. Let's solve a few questions. So this is how heights are measured. So this is height of the tower type questions you would be solving like this. And if you are solving, if you wanted to find the distance, let's take another illustration. Let's name that as illustration 1. Illustration 1. Now this is illustration 2. Now let's solve. I'm just taking a rhombus. Why? Because we are just dealing with the right angle triangle from beginning. So for just for a difference, I'm just taking a rhombus with angle 90 degree on all of its sides. Why? Because rhombus behaves like a square, and where angles are 90 degree. So for that I'm just taking it, and I would name this PQ and AB here for our sake. This is the whole angle acts as alpha, and this acts as beta, and this angle acts as gamma, and this one acts as delta. I mean, that acts as delta, and this acts as gamma. Okay, now this base is A. Now let's name it AB equal to A, and angle PAB equal to alpha, angle QAB equal to beta, angle PBA equal to gamma, and angle what QBA equal to delta. So this is what we'll consider. Now from triangle PAB, we can take it as AP divided by sine gamma. This is a law of cosines. Law of cosines and law of sines. There are two different laws, and I would just tell you after writing the equation. Okay. Law of sine is nothing but if you come across ratios dealing with sine, then you could equate that ratios along with that respective opposite sides in the form of, for example, let's I am taking sine alpha, I mean sine gamma. Sine gamma would result me with opposite side AP divided by hypotenuse PB, right? Sine gamma. AP divided by PB. And then if I am considering that sine of angle APB, it would end up getting me sine of angle APB means opposite side would be A and the hypotenuse would be PB. So while considering this as 1 and 2, then after 1 divided by 2, I would get sine gamma divided by sine of that angle APB would give me AP divided by A. Okay. So now I can rearrange this as transposing A to this side and sine gamma to this side. I would get AP by sine gamma divided by AB by AB, which is A, by sine APB, which is also equal to A divided by sine of, I'm just substituting the equations accordingly. AP and AB would be same in a rhombus. So I'm just putting like that. So A divided by sine gamma. Sine gamma here is like 180 minus alpha minus gamma here. This would act like that. And same here, 180 minus alpha minus gamma, which is also equal to A divided by sine of alpha plus gamma. So just evaluating in such a way. Same way I can do from triangle AQB. This is called specially called law of sines. AQ divided by sine delta, which is equal to AB divided by sine of angle AQB, which can also be written as A divided by sine of 180 minus beta minus delta. Sorry, gamma. With respect to that, the angles dealing are beta and gamma. And with respect to, with respect to this triangle, the angles dealing are beta and gamma. And with respect to that triangle, the angles dealing are alpha gamma and here beta delta. Sorry for clarification. Divided by sine of beta plus gamma. So these are the important equations to be noted. We equate this. Wait. So let's solve an example that deals like this. From an aeroplane vertically over a straight road. Okay. The angle of depression, they itself give the angle of depressions of two consecutive kilometer stones. Two consecutive kilometer stones on the same side are 45 degree and 60 degree. Find the height of the aeroplane. So let's just solve this equation. This is a straight road and aeroplane is flying here. Okay. Aeroplane is flying here and this is the height, and they are just telling 45 degree and 60 degree. The one how you approach would give you the farther you go, the angle would be less, and the nearer you come, the angle would be more. That's the thing you have to follow actually here. Okay, so let's name this as A, B, C, and D, and let's name this CD as X. So from this, we can write what we can write this. Okay, we can find something like that. Tan 45 is equal to H divided by BC plus X. And same way, tan 60 is equal to H divided by X. So while just evaluating, we would get H is equal to BC plus X from this tan 45. And tan 60 is root 3. So H is equal to root 3x. This is what we receive from 2. Then we have to equate accordingly. They are asking us find the height of the aeroplane. So and also they are telling that from an aeroplane vertically over a straight road, the angle of depression of 2 consecutive kilometer stone implies uh, consecutive 2 consecutive kilometer stone, in the sense for example, if the one thrown is uh, thrown at 2 kilometer, then the next stone will be thrown at 3 kilometer. In the sense, the consecutive would give us the value of BC as 1. So H is equal to 1. I mean H is equal to X plus 1, and the value of H is root 3x is given. Root 3x is equal to X plus 1. And while taking common, root 3 minus 1 of x is equal to 1. And then while substituting x, we get it as 1 minus root 3 minus 1. 1 divided by root 3 minus 1. Then we could write this as root 3 plus 1 divided by 3 minus 1, which is root 3 plus 1 by 2. That's the value of x, and we can substitute this the same in h is equal to root 3x. So h is equal to root 3 of root 3 plus 1 by 2. Now 1 by 2 can be taken out, and we can just multiply root 3. 3 plus root 3 by 2. 3 plus root 3 by 2, in the sense root 3 value is 1.732 divided by 2, which means I would get 4.732 divided by 2, which is 2.366 kilometer. So the height of the plane, which is in motion, is 2.366 kilometer. So this is how the height is found, and this is how the distance is also found. Then you could x value, then you could find x value as root 3 1.732, 2.732 divided by 2. 2.732 divided by 2 in the sense it would give me value of 1.376, I guess. 1.366 kilometer. Yeah, 1.366. I would be getting 1.366 kilometer. Height would be 2.366 kilometer, and the distance traveled, the total BC would be 2.366, which means this is 1, this is 1.366 kilometer, and that would be 1 kilometer, and this would be 1.366 kilometer. So hence this is the value. Sorry, this is 2.366. Yeah. So this is how the trigonometry is applied in finding the heights and the distance of the triangle in terms of using the right angle triangle as a consideration for finding the height of tower or finding the height of anything which is in motion in air. Even more problems based on this concept and based on this scenario. The simple thing is, whatever scenario you get, you just make use of it using tan and cot ratio for this type of problems, because you would be dealing with just tan and cot in this particular thing. There isn't any use of sine and cos. Mostly, most rarely you will be using that. Mostly you will be using the tan and cot only. So just remember those tan angle formulas alone. You can easily do this up. Please like, share, and subscribe. And thank you. Meet you on next episode, next video.